Inverse trig functions, review of the inverse trig function. To have an inverse, a function needs to be one-to-one. The sine function, defined over all real numbers, is not one-to-one. For example, notice that there are many locations where sine takes on the value of 1/2. But if we restrict the domain of sine, we achieve a function that is one-to-one. Now there is only one location where sine takes on the value of 1/2. An inverse trig function gives angle. For example, if theta equals inverse sine of opposite over hypotenuse, this tells you to find the angle whose sine has a ratio of opposite over hypotenuse. Find the exact value of inverse sine radical 2 over 2. Recall that we restricted the domain of sine to be between negative pi over 2 to pi over 2, so that when we look for theta, we must look for our answer there. Notice that the unit circle shown has the angles in the fourth quadrant written as negative angles. Also recall that as you look at the ordered pairs of a unit circle, the first guy gives you cosine and the second guy gives you sine. Find the exact value of inverse sine of radical 2 over 2. Well, sine, if theta equals inverse sine of radical 2 over 2, then sine of theta would have to be radical 2 over 2. And sine of theta is equal to radical 2 over 2 precisely when theta equals pi over 4. Find the exact value of inverse sine of negative 1/2. That's the same as saying sine of our mystery angle equals negative 1/2. And that occurs at negative pi over 6. Likewise, we restrict the domain of tangent so that we can define an inverse function for tangent as well. Let's find the exact value of inverse tan of negative radical 3. Well, that means our mystery angle, theta, has the property that tangent of theta equals negative radical 3. So sine of theta over cosine theta equals negative radical 3. Now, I'm writing it in kind of a funny way, but in doing that, I can see where my ordered pair is. And so theta would be negative pi over 3. To obtain a domain for cosine that is one-to-one, we start at 0 and go up to pi. Find the exact value of inverse cosine of negative radical 3 over 2. So our mystery angle theta has the property that cosine of theta equals negative radical 3 over 2. And that occurs when theta is equal to 5 pi over 6. Find the exact value of inverse secant of radical 2. So our mystery angle has the property that secant of theta equals radical 2. And so cosine equals 1 over radical 2 or radical 2 over 2. And that occurs when theta is equal to pi over 4. We can define, we did inverse sine, inverse cosine, and inverse tangent. We can also do this for, inverse cotangent, inverse secant, and inverse cosecant. I will see you in part 2. Take care and have a great day.